Okay, so we're moving on to a different type of transformation today. Today it's called a reflection. So reflecting things across different types of lines on the x-axis or the y-axis or the coordinate plane. This is a type of reflection. The water makes a nice reflective surface. A mirror shows you your reflection, which things are the exact same as they were at the beginning.
Corbin.
Okay,
Fisher,
so
to the cafeteria. Corbin.
What we're going to see here, reflections on the coordinate plane. If they want us to reflect something over the x-axis, to reflect a figure over the x-axis, multiply the y-coordinate by -1, which just means change the sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. If it's over the x-axis, x stays the same. If it's over the y-axis, y stays the same, and x change the sign. And you can see here, here's my, over the x-axis, here's my x-axis, they reflected it, and it over down there. Here, the y-axis, they reflect it. It's as if they folded in half, it would look the exact same. So these look the exact same if you were to fold them hot dog style or hamburger style. That's kind of what we're looking at. Hamburger, hot dog. They would land on top of each other. Here's a vocab word, a couple of them. A reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called a line of reflection. A line of reflection is a line, you might have to look this one up, it's kind of an awkward definition in here. A line over which a figure is reflected. That's pretty accurate. In a reflection, each point of the preimage and its image are the same distance from the line of reflection. So in a reflection, the image is congruent to the preimage. So over the y-axis, remember this is y stays the same. That's like hot dog style. Over the x-axis, x stays the same. In reflection and translations, the image is congruent, meaning it should be the same shape and size as the original. Okay. Triangle ABC has vertices blah, blah, blah. Graph the figure and its reflected image over the x-axis. Then find the coordinates of the reflected image. So we're going to have to do A prime, B prime, and C prime. So 5, 2 for A. 4, 5, 1, 2. That's A. B is 1, 3. 1, 1, 2, 3. And C is -1, 1. Okay, so I'm going to use a different colored utensil again to reflect it over the x-axis. So if I reflect it over the x-axis, that means all the x's should stay the same. So this should be 5, this should be 1, and this should be -1. The y's flip their sign. So 2 becomes -2, 3 becomes -3, and 1 becomes -1. And so then we should be able to plot these. 5, -2, 1, that's A prime. B prime is 1, -3. And C is -1, -1. So if it doesn't look like we folded it along the x-axis hot dog, a hamburger style, it does, so we're good. Just reflecting. It's the same size, same shape, angles are the same, side lengths are the same, so reflection. Quadrilateral, KLMN, has vertices 2, 3, kind of awkward lines here, 2, 3, 5, 1, 4, -2, and N, oh geez, I should probably label these K, L, M, N, 1, -1. So looks quadrilateral, four-sided shape. Doesn't really look like a rectangle, more like a trapezoid. Graph the figure and its reflection over the y-axis. So this is hot dog style. So KLMN prime, the new image. The y-axis means that the y-coordinates stay the same. So Our y-coordinate here would be 3, and at the x-axis, y-axis means that the x needs to change. And L, we'd have go from 5 to -5, keep the 1. M, we go from 4 to -4, keep the -2. N, we'd go from 1 to -1 and keep the -1. Now those should correspond on the other side of the y-axis as if we folded it hot dog style. So -2, 3, k prime, which is 2 away, 2 away. L is -5, 1, just like it is over there. 5 away, 5 away. Although my lines might be a little off because I can't see the lines. -4, -2, and a -1, -1. 1 distance away, 1 away. Perfect. So some people like to visualize and then find the coordinates. Some people find the coordinates and then visualize. Kind of your choice. Okay, triangle PQR has vertices blah, blah, blah. So P is at 1, 5, 2, 5. Q is at 3, 7, 3, 5, 6, 7. And R is 4, -1. 1, 2, 3, 4. Reflected over the y-axis. So if I do this with, if I do the graphing it first, I can look at it like this, that P is 1 distance away here, so it would be 1 away here. Q is 1, 2, 3 away here, so same line, 2, 3 here. R is 1, 2, 3, 4 away, so 1, 2, 3, 4 away. So that time I graphed it just using what I know, and then I can find the coordinates. P prime was -1, 5. Q prime is -3, 7. And R prime is -4, -1. Which is the same as if I had just flipped the signs of the x's because I reflected over the y-axis. The coordinates of the point and its image after reflection are given. Describe the reflection over. Is it over the x or is it over the y? So just remember, x-axis, reflection over the x-axis, the y changes. Reflection over the y-axis, the x changes. So here, the x went from -3 to 3. So since the x changes, it's the y-axis. The y stayed the same. Or you could talk about x-axis, x is the same. Y-axis, y is the same. That might be a little bit easier. So which one of these is the same? The x. So x-axis. And there we have it. Here's a couple pictures, some cool reflections, letters in the alphabet that have reflections. This is a design, a mosaic, probably the floor or ceiling of some building. Has some cool reflections. We're going to add to our foldable that we were doing the other day, reflection. So model it. I would use algebra and just say that x-axis, I basically would say that regular xy becomes x negative y. In the y-axis, we go from xy to negative xy. And then, or I guess I could have drawn it there. That's probably a better spot to draw it. Symbols might have been this one. That's okay. So if I draw it something like this, reflection over the y-axis, let's just draw, I'm going to draw an easy peasy triangle. Over the y-axis, it would go here. And I'll put this one in a different color. We'll call this A prime, B prime, C prime. And go back and label this. There we go. So that's something that might help me later. Have a great day.